Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. We are at the second Tuesday of the month, so Advanced DBA time. And tonight, we have the pleasure of Pablo Lozano, who's going to talk to us about a central query store solution, which is incredibly cool. Pablo is coming at us from Madrid. You are in Madrid, right?
Yes, I'm in Madrid.
Okay, yeah, I thought so. I knew you were at the Madrid office, but
Yes.
didn't know if you had moved out of there. So from Madrid, so it is a little bit late. It's what, midnight?
Yeah, midnight.
Nonetheless, we appreciate you taking the time so late to talk to us about CentralQDS. So let's take it away, and I'll hand it right off to you.
Okay, so the title for the presentation that I submitted was a bit long, so it's just summarized that Central QDS or Central Query Data Store or Central Query Store, whatever you want to call it, is just Query Store but up to 11. So a little bit about me. Just wanted to summarize that 29 years of experience using mix of Paint, something like or similar, but I haven't improved anything at all. Just the basic to do some very basic means for my colleagues. 12 years of experience as a SQL Server DBA, which of them they were pretty much 100% time with SQL Server, but with the exception of like 6 months working with Wintel, since there was not much activity on the SQL Server where I was working. And I've been working with Query Store since 2019 on SQL Server for the version SQL Server 2017. My Twitter is there at SQL Lozano. My website www.sqllozano.com, and my LinkedIn is there. And I'm also on the SQL community Slack, same at SQL Lozano. And I usually check and I have some alerts when someone mentions Query Store, so maybe I can jump in. Okay, so Query Store, if any you has already been using that for a while, you know that it's great because it has a very low impact. It's much better than the old profiler that I used to love for many years. I like it even better than the extended events. And it can gather some information that you can do with extended events. You can aggregate data on some certain levels, but Query Store does in a much greater scale. So you can find queries that consume the most resource on a certain database. That might be 10 dB usage, either read or write pages on logical level, on the physical level, duration of the queries, CPU usage, you name it, it gathers pretty much all kind of information. With that information, Query Store can give you information about the queries whose performance has changed due to a planned regression, any ways that might have affected its duration based on previous executions. And it can also use it. You can also use it, or actually, SQL Server can be configured with automated plan regression to do it itself to force a SQL query to use a certain execution plan. So if you have a particular if you're supporting a particular application that you can't modify the code, you can modify the query so that they use query hints, but you see that sometimes SQL Server picks a better plan. You can force. I usually prefer the term persuade because it doesn't work 100% of the time. So you can try to persuade SQL Server to use whenever possible a particular execution plan. Oh, sorry. But sometimes Query Store is not that good on some specific scenarios. So you may have different queries, similar queries with tiny difference. So let's say you have a store procedure, you make a change on the query and you add a comma or you add quotes. For SQL Server, that's a completely different query. So you can just see what's different in the query because from the SQL Server point of view, any character that has changed any tiny different is a completely different query. And if you use non-parameterized queries, if you execute dynamic SQL with the parameters generated or included in the dynamic query, those from the Query Store standpoint are completely different queries, so you can't compare them. If you use some some framework like entity framework or similar things that they create dynamic queries, or they modify queries with tiny difference, or if the filters maybe they are some small changes like adding a blank space here and there, or just adding the parameter in the code itself instead of as a parameter. You will see that those can be different hundreds of different queries, even though you are not making pretty much any change. Another issue with query store is that the information that query store gathers, first it's taking up some space in memory, but then it's stored persisted into the disk, and that goes always into the primary file group. So when you create a database and you think that you may end up with hundreds of gigabytes of query store data, if you have experience with query store data, you have to account for that, and the only way to try to prevent this from being an issue is just have the primary file group only for query store, and then create different file groups for any other kind of information, so you can keep them separated. There are also some limitations. So if you have dozens of databases in an instance and you're having issues but don't know which one is causing the issue, you will have to open every single one of them. So you'll have to go check what is the top CPU query on each of the databases, try to figure out which one is the worst, or aggregate all those queries on each database and figure out which one of the databases is the top consumer of CPU, 10 dB, you name it, and try to figure out which one is it, and then out of that database narrow it down to one particular query or a set of queries. That can be easy to do when you only have 4 or 5 databases, but in our environment, I think we had a server with about 400 or 500 databases, so that was not feasible. And then, unless you have you ever have a need to compare query store reports from multiple databases or servers, that's something that you cannot do, because all the unique IDs are going to be different, and the scale of the graphs are going to be different. So it's not just as taking a screenshot of the chart and then comparing to another, and that could only be done with maybe 2-3 databases. But when you have let's say you have multi-tenant, or you have multiple different databases, one per client or per environment, that you want to compare that, that's something that you can do unless it's just a minimum amount of databases, let's say 2-3, that you can eye the difference between them. And then there are a lot of bugs. I just wanted to include this because I recently found, I think, 4 or 5 extra query store bugs. So that's something that you also have to account for. There, some of those are very edge scenarios that you will likely not find, not find in a regular environment or regular workload. But there are some. I just wanted to point out that this is not perfect. So the first solution we developed was a QDS toolbox. This is already released. It's in GitHub, so you can just go into GitHub and look for QDS toolbox. And this was a T-SQL only tool to extract data from query store. So the advantages compared to the regular query store interface is that you can run that on all databases at the same time. So as I mentioned, you want to find out what does the query that is consuming the most CPU on the whole server, and you have 20 databases. You can just run one command and it will scan all the databases, generate the top queries from every single database, and it will give you a summary, and you can also store that summary in a separate table. Pretty much everything I built on this tool can be automated, and you can just run any report and store it into a table. So you can just run the report at 3 a.m., schedule that, and next day check what were the metrics. There are some other reports that were not included in Management Studios GUI, like the system databases. The MSDB is a system database. So if you look into the documentation from Query Store, they mentioned that this is not supported for system databases, but it is supported in MSDB. What is not supported is the reporting system. So we had an issue with involving replication and hundreds of jobs writing into the MSDB and cleaning up the jobs from there. There was some contention there. So we had to enable query store on the MSDB so we could troubleshoot what was the issue, where was the blocking, where were the queries, whether we have to create customized indexes for our particular queries to improve the performance. So that's something that out of the box SQL Server will not allow you. Some other reports are, in addition to the query regression, which is included on the report, on the default reports, we decide to create also the improve queries. So if you decide to try to add an index and see what's the impact, you can see what queries were hampered by that, which queries running worse, like maybe some inserts, but you can see which ones are performing better now. And this report also allows for extra parameterization. So let's say you want to test what would be the performance of your application if you double the memory or double the CPU, the number of CPU or the speed of the CPUs. You can select to, okay, just give me the queries that have improved with only one plan or that have improved in a certain amount. There are some parameters, I can't remember which one because this was about a year ago, but there are some parameters that you can set to narrow it down the reports that by default they're very basic. There's something like minimum number of plans. You couldn't set the maximum number of plans. There were some values that you could set minimum but not value maximums. So I decided to include those to the report so you could just tailor whatever you wanted to identify. Also, that this is something that we use a lot because there are some queries, as I mentioned, that you can't force the plan. You can only ask SQL Server to ask this plan whether available. But there are some scenarios like when you're using table variables or temp tables that in those cases, forcing the plan will not work unless in specific scenarios. So for that, this tool also lets you give in a query ID or an object or a list of query IDs that you have identified that have issues or have regrets because of are using older plans or non-optimal plans. You can run a command and this tool will give you the list of statistics that are being used by the particular query. This is extracted from the execution plan, and it will get the statistics used by those plans, compare that with the current statistics, and it will suggest you whether you should update some specific statistics, leave them alone because they're being rebuilt very recently over a high degree or sample. So you can decide which ones are worth being updated. And another thing is that we improved the cleanup process. The old process we were having issues, so we have an incident with one server that there were only, I think, was 2 databases that were running the usual cleanup process that Query Store will do, and it was hammering the server. And when we look into the code, we tried to figure out what was going on. We realized that it was a very dumb cleanup. So we included some parameters like let's say you want to get rid of all the queries that are not part of an object because there's just developers testing, or you want to get rid of metrics for an object that has been dropped. So you can just get rid of that. And when we changed that, we were able to run this cleanup process on dozens of databases on the same server, and there was no impact on the server at all. But the main start for the presentation is CentralQDS. So CentralQDS copies query store data from any number of databases into a central database. So when we were picking on the number of databases, I think we were capturing data from about 4,000 or 5,000 databases into a single database. We also reduce the space that is used by all this data by compressing data and removing duplicates. This includes query text, which is not being compressed properly. We found that there were just running the compress function on the query text will greatly improve the space savings, and also for the execution plans. So that's for the compression, we compress those metrics, and also we remove duplicates because since we have maybe dozens or hundreds of different databases that are basically the same copy of the database, we know that the query text is the same. We don't really need 100 query texts with the same text. We don't really need hundreds of thousands of execution plans, which are basically the same. So when we capture the information on each server will have its local log copy. But when we aggregate that, we reduce the amount of space by just getting rid of all these duplicates. Another way we reduce the space is that all these metrics that we capture, either at a 5 minutes interval, 15 minutes interval, 1 hour interval, whatever you have set on your particular on your local database on each server, we decided to aggregate them at the day level. So every day after midnight UTC, because query storage uses UTC. So every night after midnight, we run this process, aggregates all this data, and we have by the next day we already have all the metrics with what was going on the previous day. This is not a live reporting tool or live monitoring tool like the previous one, like QDS toolbox will be. This is just for comparing hundreds of databases. Another way that it reduces the not only the size but also helps identify the similar queries that, as I mentioned, these queries that have tiny difference like a comma here and there, a black space here and there, or just even using lowercase or uppercase. Those queries can also be aggregated based on the query hashes and some other hashes that query store stores there. And since we have all this information stored in a single location, we can make comparison between different databases. We can see how one particular query run on any number of different databases, because at this point we already know what is the we don't have the local query IDs or the local plan IDs. We have already assigned a warehouse key for each one of them that they are unique, and they are mapped to each local query ID, each local plan ID. So we can translate from a local server to a central server and the other way around. And this lets us, given a particular plan that is pretty much the same with just the different database name across all the databases, we can see how is that plan or how is that query performing across all the servers. And we can have fancy dashboards, which for the demo there will be not as fancy, but I couldn't use our production data. But trust me, they're very fancy, and we have I think we have 2 dozens of them, but I just made a single one for the demo. And since I wanted this to be flexible enough so everybody could be using that, and when I was writing the whole thing, I was thinking, how would I deploy this on my previous job or on the previous one on the previous one? So it lets you organize the instances and databases at a different level. So you can organize instances by the environment. So I work in a place where the first letter will be the environment. The second letter, I think, will be the country. The third will be the stage, something like between 1 and 4. I don't remember the details. In the same place, the databases will be something like the 4 different categories will be the country. The 5th will be the environment. 6 to 8 will be the application code. So I was thinking how this could be applied so anyone these kind of weird environments or weird settings could be configured. And this allows you to configure a group of databases. So let's say you want to configure a group of databases, and this group of databases will be application A. And you have that particular group of databases has a particular name pattern. So you can configure those databases in the same group. Then you can set up queues. Queues will be how CentralQDS will connect to a particular queue, which can combine any number of instances of databases to gather information from them. And then the sets, which is the level at which the data is aggregated and is then later used for the reports. So let's say you want to organize your database on different applications, and then you have different queues. So let's say you want to gather information from these servers from 1 to 2 a.m. Then you want to have another queue from 2 to 3 because the workload on the servers is lower at the time. You can configure the groups, the queues, and then once all these queues and the groups have been loaded, you can just run the part that will aggregate the data into these sets, and that's when you get all the data ready for the reports. Also, in terms of configuration, in the original versions, we had only one or two different file groups, and that was a mess because we wanted to add another disk. We had to create files on that file group. When I started creating new schemas and new objects, I had to decide whether to create new file groups or new files inside the same file group. And this is a completely separate one. So you can have a file group and store all the databases information in that file group. You can have a file group with the name of the particular database or a particular application, and you know that everything that is inside there is related to that particular application in case you want to keep track of how much space you are consuming for one particular database or one particular database type. And you can also do that on the database and on the database level. So it's pretty configurable. I have some configured here for the demonstration, but you can just go with the default and have everything in the same place. And also for these file groups, the data files can be configured in number, size, and location, which is very important because when I was doing stress tests on different versions of this tool, different number of databases and different parallelism, and different number of CPU and memory on the box that was running all these reports, I realized that I was reaching a point where I was getting issues with the number of files. I was getting hot pages. I was getting all kind of weights because I was hitting the same mount points or the same files. So I had to tweak that up, and I wanted this to be configurable by whoever wants to try this, so they can adapt that to their environment. And also in the configuration, you can decide what kind of cleanup you want to do. So since all the raw data from the local query store for each individual database is being gathered here into the CentralQDS, you can decide that you want to keep the data as it is. You can decide that once you have aggregated data, you want to get rid of that data completely, so you save a space. You can to decide which indexes to rebuild. There are some defaults I have already configured to decide whether to rebuild all the indexes, just the PKs. There are some sort of maintenance that I could think of that I try to be able to configure with all these ideas I had in mind. But yeah, there will be someone that will probably come up with some other ideas that I haven't think of yet. And how the data gathering works. So it gets a list of databases, which is what I call the database queues, and it connects to each of them in parallel. This is done by the combination of SSIS packages, asynchronous execution of the SSIS packages invoked by SQL, which logs into a table on kind of information. This is also customizable, so you can decide how many databases you will extract information from, how many databases per instance. So if you consider that this data gathering is consuming too much CPU or putting too much pressure on each server, you may want to throttle it down so it can only connect to one database at a time on each server. Or if you're okay, you can just run it on all the databases on the same server at the same time. And also you can decide the delay between each execution, since it's a parallel process, but it's not a fully parallel process. It's just a loop that it will invoke the SSIS packages. And on my test, I found that if I wait less than, I think it was 0.5 seconds, the SSIS database will start having issues with blocking all that kind of stuff. So I had to limit that to, I think it's 0.75 or 1 second of delay. Because of the way this is configured, all these databases have their own schemas, and that's where all the information is gathered and how the aggregation is performed. There is no blocking at all. The only blocking happens on the queue table, on the queues that aggregate that they store information pertaining to each database. Something like keeping track of what was the last plan ID that was loaded, the last the last interval that was loading to the process, that's the only place where the blocking happens. And when I just tried to perform a stress test, the only limit was the CPU. There is some blocking on those particular tables, but most of the processes are happening either on specific schemas for each database or happening on the individual servers. So there is no much impact on this box, just the CPU that is going to do the aggregation, the cleanup, all this process. So whenever I run this, I know the server is going to be hitting 100 CPU, and I was getting very angry when I was running tests and the CPU was not hitting 100 CPU. So I kept increasing the number of parallel processes because I wanted this to be run as fast as I could. Uh, this information that is stored, this table I mentioned that is where the blocking is happening, is where I keep this information, these IDs and the timings that allow me to perform only incremental loads. So when I run this on a database for the first time, it might take 5-10 minutes to get all the information and do all the aggregation, the cleanup, the compression of the data. But the next time you will only get the information from the previous run to the current one. So the more frequent I run this process, the faster it gets. There is a limit that I cannot reduce because there is some maintenance processes and there are some aggregation that has to happen and has to scan the whole tables. But this reduces as much as I can the network traffic, the activity on the server, and that's something that I wanted to make sure that I was saving a lot of time and network traffic, thinking about people that might want to use this against instances they have on AWS, and they may not want to spend a lot of time querying them or a lot of money on the network traffic. And also for this data gathering, I have some queries that will gather data. So by default, the ones I have extract all the data. If you ever look into the tables that store the query store data, they have all kind of metrics, and I'm capturing that information. But if you really don't want to know, I don't know, maybe the CLR weights or the 10 dB usage, you can just modify the query and just return null for those values, and that will save you some time, some space, some network usage. You can modify it as you want. And about the storing and processing data, as I mentioned, each database has its query store data duplicated on its own schema, something like DB0001, 002. The query text and execution plans are compressed with this compress and decompress function from SQL Server. There's nothing weird there. All the duplicates are removed using the hashes provided by query store. And there is also some steps that I added that it will extract the information from the execution plans. So in cursors used, tables used, statistics used, columns that the query is accessing, whether it's accessing it for read operations, for write operations, I'm extracting all this information. This is based on one of the components of the QDS toolbox. I made some changes here to adapt that for CentralQDS, but the whole process that gathers data already does all this processing. So I will show you some examples here of what can you do with that kind of information. And as I mentioned, the raw data is aggregated at the day level, and it's aggregated at the plan level, which is the default by query store. So again, if you ever look into the query store of data and you query the tables themselves, you see that it's stored at the plan level. But in order to make it faster for the report to be executed and also to get rid of duplicates and all that, I decided to read this data at the plan level, the query level, the query hash level, and the object level. And regarding data savings that I mentioned about compression or how this can save you space in the server. So obviously the runtime and wait stats, you will save time depending on what's the intervals you have on your original servers. So since I'm aggregating data at the day level, just basically if you're using hour intervals, it will only take 1/24 of the space roughly, because this depends on the intervals of how many rows on each interval, or the amount of activity or different queries. And if you use 15 minutes interval, it will get you almost only 1% of the usage you normally consume. And this is some numbers that I got by comparing the query text and just compressing the same query text. So query text is compressed to about 20% of the normal usage, and for execution plans, that goes down to only 7%. And this is just for each database. That's why I mentioned additional levels are applied if multiple copies of the database are being aggregated. So this will be for the database level, but as I mentioned, this database set level, this will get all the query text for each database, all the execution plans for each database, remove duplicates. So if you have 100 queries, you are saving, you are only storing one query text instead of 100 query text, and you are only taking 1/4 of the query text space. So that's you're not going to be saving space on each individual database, but when you aggregate that on the central server, you can be sure that the central server will take way more space, way less space that each individual database has. So with this in mind, you can go from storing one whole year of query store data on your individual databases to just having to keep maybe 30 days, so you can still use the Management Studio built-in reports, and you will still have this one whole year of data into a database, and it will not cost you as much storage as having that data in your live server will. So here are some comparisons for 10 copies of the same database. So let's say you have hourly intervals and 10 gigabytes of query text, 15 gigabytes of execution plans. That will be 350 gigabytes. But that amount of data, when you store that into CentralQDS, it will go down to maybe 21 gigabytes. So that's a real space, safer space. And yeah, since you don't have to keep all that information, you can save on the individual servers. You don't really need to keep all that information there unless you really want to use the report to scan all that data, and you still have these metrics, not as granular as the 50 minutes or hourly minutes, but you can have some archive of that information on the date level. And about the reports, so there are some TSQL reports that are fully parameterized. So you can get information for each database, for all databases. That would be an aggregation of the metrics for each individual database or for a single database. You can also decide to filter that by a particular plan or query hash or object. So let's say you don't really like running the Power BI reports, or you're not really a fan of Power BI reports like I am. So you can just run a query and it will give you on a grid what are the metrics for that particular query or for the particular database. And I haven't compared for a while, but this used to be way faster to run that scanning a whole year worth of query store data on a particular server. And you are also offloading all that activity into a separate server. Also, these reports will let you filter by specific threshold. So let's say you want to see one particular query on which servers it had an average duration of maybe 3-4 seconds. You can filter those values there. In addition to those reports, you have the predefined Power BI reports, which right now are not predefined because I just made it on the fly, but my idea will be to have some pre-built Power BI reports once this gets released. And there are some other stored procedures in place that can get you information from the execution plans, which, as I mentioned, is based on some code I had for the QDS toolbox. Some examples of those are index usage in missing indexes. So again, there is no dashboard here for that. It's something that we have internally, but we have dashboards that will let you see what are the indexes being used or what are the missing indexes on which databases those indexes are missed. The operations performed. So let's say you want to find. So let's say you have no idea what the code does because you're a purely DBA, you're not touching the code or application at all, but you want to find out which one of these queries or these objects are using cursors. So you can just go ahead and just look for any activity that's using cursors, or you can just look for any execution plan, and with the execution plan get the queries that can use index scanning or index lookup. So you can get this information which is being extracted from the execution plans. And also you can get information about all these the objects were accessed. I think I saw Anders that was going to join the meetup, and this was specifically because Anders Pedersen was complaining about this on a team meeting where we were working in the same company. So I didn't forget about that. It just took me a while to generate that. But now you can just, if you are planning on making a change on a particular column and you want to find out what it will break, you can just run this kind of command, and it will tell you exactly what is accessing that column, what is reading into that column, what is reading or writing into that column, all this information. And same for indexes, you can find what will be the impact if you decide to drop one particular index, what queries will be impacted, and based on that decide whether it is worth it or not. And if you decide to go ahead and drop that index, you can then go with that information and just run all these reports. As I mentioned here, this filter by plan, query hash, or object. Since you already know what were the objects that were using that index for any of the queries, you can see whether that particular object is now performing better now that you drop that index, or just now that you modify that index. There are some custom reports that you can build on top of this. Some of these are based on what we currently have for our version, which we are not running on the version I'm gonna demo. We're running the previous one. So we have some kind of reports. Well, mostly the DBEs. I'm working on the DBA team. So they have the worst procedures to log into. So I think it's every quarter they generate a list of all the worst procedures, and they just work on improving them. And then the next quarter they go into the next list of worst procedures, and that's how they keep the application as fast as possible. Another one that we have is report of regressing, improving procedures, comparing current and historical metrics, and we also usually use this to find out if there is any issue. If someone has made any change, we can identify what were the changes, or what went south when something happened that we didn't foresee that it will have any impact, or what is performing much better because we modify. We created, or well, me or the DBs created an index, and suddenly some other queries are performing way better. So we can find out those out without having to go and check all the thousands or millions of different queries that are running. You can just go ahead and go what went wrong, what is going better. And we have this other filter. This is based on, so this is a combination of different tools we have, but in our dashboards, we can just given a dashboard with all the metrics. So we have metrics like graphs showing us the CPU or duration of a particular store procedure. We can also filter all the objects or the store procedure that were modified in for a particular ticket or for a particular change request. We can filter those out. So when you go into a dashboard with maybe hundreds of thousands of different store procedures, you don't really need to try to remember which ones were them, or go in Power BI and start typing every single one. You can just pick, okay, I want to find out what were the changes on this subject that were in scope for this particular change, and it will already filter that. So that's something that you can build on top. Well, this particular one with some extra steps, but that's some kind of information that you can get from here, especially the worst procedures. I think this is the one that is looked into the most by our team, and they constantly report what were the improvements they made. So that's something that they really look into every single week, or maybe every single morning. Oh, what's it's good for you? What's CentralQDS good for you? So as I mentioned, if you want to create or modify indexes, After the day is over and you get the new information, you can find the queries that are using the new credibly indexes with all these custom reports that can get information from the execution plan. Indices that can be dropped. So yeah, with all the information you have on the indexes, you can just find indexes that are being used for read operations, but let's say scan or seek, but never for updates or inserts. And then this is a scenario very complex. So let's say that you have, let's say, multiple databases for different clients, which pretty much the same database with the same application, and you decide to deploy an index because one particular client is complaining about a report. So you really want to know, and you really want to make sure that when you're creating an index for that particular customer, if you want to deploy that to all the different copies of your database, you want to make sure that whatever is being used by that index is going great. So maybe you're, as I mentioned here, maybe one particular client is just performing generating reports and the data is pretty much static, but there is some other client that on their copy of the database they're just updating the same data over and over again, and by adding those indexes, you're making all these operations to update one extra index, and you really don't want that. So you want to decide the pros and cons of adding or removing indexes with all these reports, all this information. Uh, you can track procedures, triggers, and functions. So for Query Store, one of the main problems is that if you are too used or your developers are too used to just drop and recreate objects because that's how it has always been done, when you do that, the object ID changes, the query ID changes, the plan ID changes, everything changes. So you lose track of that. So if you are using the old Query Store to keep track of that query and you decide to make a tiny change, if you run a drop and create the object, you lost track of that query ID. You can no longer compare them using Query Store. You have to keep track of the old query ID, figure out what's the new query ID, compare them side by side, and that's something that is very annoying. But since Query Store uses for instead of the object ID, it uses a query hash based on the object ID. So no matter if you drop and recreate the object, that hash will remain the same. It also keeps track of the query, not instead of just the query ID or the plan ID, it uses the hash for the particular query and the hash for a particular plan. So that's less likely to change. There are some scenarios where there are some weird stuff with the query IDs and the query hash, but most of the times that hash will remain the same, and you can still compare them. Some other things that you can do with that is, yeah, as I mentioned, since you can find what are the objects using one particular column, you know that if you want to change a data type or drop a column, you know what code you need to modify. Yeah, because sometimes it's not as easy to just find the column name. There might be aliases involved, but since this information is directly from the execution plan, you get the actual name of the columns, the actual name of the table, so there is no additional layer to translate that into the actual value. And you can find read-only objects, which just pretty much it just scans the execution plan if it doesn't find any read operation or just read operations that are not just TempDB or table variables. It will just consider that's a read-only object, which is something that you can use to identify what objects are safe to grant access to. You should still look into that to make sure that there is no error there, but that will be a great help, and it will be a first filter for those objects. And also, if you, like myself, have to deal with entity framework queries or pretty much any kind of other queries, you know that those are very hard to compare. So whenever we have an issue and someone is complaining about an entity framework or another query, there is no way I can try that query or I confirm if that query is performing better or not, because next time, in some cases, there was something like they had the current date inside the dynamic query, so there was no way I could just compare the query. But Query Store uses the hashes, I uses some comparisons to get rid of all these tiny difference, to ignore them, and that way you can just compare all these queries that are pretty much the same. think that's the last slide. Yeah, so time for a little bit of a demo. So
So,
this is the dashboard I have. This is
oh,
just a
sorry, Pablo.
sorry.
Before the demo, there
Yeah.
was a question in chat that I did want to ask about, and maybe a little bit unrelated, but does pertain to Query Store. And that's in regressed queries, it'll show multiple plans. And how do you know which plan is currently used? I figured maybe you'd show something like that in the demo, but I wanted to call it out as a question.
Well, I didn't include it in the demo because I wanted to avoid using Query Store at all because on a daily basis, I pretty much try to avoid using the interface. I use my own queries and my tools. So when you see the well, I can connect to. Okay, let's see. Well, these are very basic queries, so there is no plan regression. It better doesn't have any plan regression because that's the one I'm working for Query Store. So you may have here different plans, and the SQL Server can jump from one to another even in the same minute or in the same I think it's a 15 minutes interval. So the current plan is always the last one. You can even force them, but the SQL Server can ignore it. The only way to confirm what's the actual plan is just wait for the last execution and see what's going on. Yeah, SQL Server will not tell you what's going to be the next one. You can just only hope that it's going to be the right one or it's going to be the previous one. But sometimes when we are rebuilding indexes or updating statistics, and there is a query that is running every few seconds, you can see how the query will go from one plan, then will pop up another plan that might be performing better. Maybe then it's another plan that turns out that it works, but SQL Server doesn't know it's going to be worse, so it's going to be still using that. And there may be some jumping up and down until it stabilizes and decide to pick one particular plan. And if there are no more changes, they will try to stick to that plan unless there are some issues that cause that plan to suddenly run too slow, and then SQL Server will reconsider any of the previous plans, or sometimes even create a brand new plan. But yeah, the only way to decide what's going to be what's the plan the SQL Server is using is just hoping that the last one you saw is the next one is going to be using. But unless you are forcing the plan and there are some specific scenarios that it will enforce that particular plan, there is no guarantee. No, unless the plan is so simple that there's no way SQL Server can mess that up. Any more questions?
No other questions at the moment, but chat, if you do have questions, put them in there and we'll get them answered in a appropriate time and place.
Yeah, before I open my ugly Power BI and scare all of you.
Yeah, it may be good to let's continue on, and then if there are more questions, I'll hold them until after the demo. Oh, tested on all
Mhm.
current versions of SQL Server.
Not on 2022. I did some tests in 2022. They added some features, but that's the main reason I use such a huge font on the bugs part. There are so many bugs there. So many. I found bugs while trying to reproduce previous bugs.
Wow.
Yeah. Yeah, so I haven't tried that out. So, well, the query, these commands will run. So, because I tried capturing data from SQL 2022, but the queries and the object are not ready for 2022. So there are some additional tables, sorry, some additional columns there, or some additional tables that are not included in my queries because I wanted to make sure that it will work until up to 2019. And also, there are some columns that have changed names in between SQL Server and Azure SQL Server. So if you ever go into the documentation from Query Store and you try to copy and paste for the purpose of writing your query into SQL Server, some of them will fail because they didn't mention that, yeah, this is just for this particular uh, uh, server or whatever, or this particular version. So there are names that will not be, they will not match. Any more?
No questions at the moment.
Okay. So this is a sample dashboard for using Power BI. It's a bit crude because I don't like Power BI, and it just has the basics. So I added a page with all the filters so it would be easier to read. Here we have the object W key, the warehouse key, but this for in your case, or you modify that, this will be the object name, so it will be easier. Right now, yes, this doesn't make sense. I think the first maybe 200, 300 are just the systems to procedures and functions. I don't remember. And this plan WK, query WK, and query hash unique WK are just internal values. These are not the local ones that you can get on your instance. It's just the information that after I'm removing all the duplicates, all the aggregation and compression, this is the kind of information I have here. And the filters, I don't think they are worth, but here I was looking. So this query hash, this unique query hash, as you can see, there are plenty of queries, but there is only one plan. So I'll have some explanation for this here, but this is pretty much that all these queries have tiny difference. So maybe just the, as I mentioned, maybe just the date, or just in the word clause there is a value that is hard coded there. But these queries, as you can see, they are using all the same plan, and they are pretty much the same query. But since they are tiny difference, for SQL Server they are considering all these different queries. And some other filters you can use, just filter the aborted queries, the ones that end with exception, with a regular execution, whether you want to filter or include internal queries, which are index reveal operations, backup, statistics update. You can exclude or include them here. And these are also, well, I was going to open the details, but I just remember that there are some details of our environment, so fully qualified domains. But all this is based on the reports that I will show later in T-SQL. So you can modify all this. So if you want to keep an offline copy of the dashboard with only a few particular queries, and you need to show that to your manager, to the business, or to the client, or whoever, and they want a fancy dashboard, but you don't want them to have a 2 gigabytes dashboard, you can just specify all these filters. So let's say you only want the details for one particular database, or one particular query, or a particular object. You can modify or adjust the parameters. So this dashboard will only get information for that information. So for the particular case. And some examples I have here is the database stats. So you can show. We usually use this to identify queries that are regularly timing out, or there is some issue. So let's say here, yeah, out of these, I don't even, what, 2 billion? Yeah, 2 billion executions, only 800 ended up with an exception. Yeah, so if you filter that for a specific object or a specific query or whatever, you can see how many exceptions or how many executions have been aborted. You have metrics for the wait stats, which I just changed the chart a little bit so show a different kind of report. And you can filter here. In the filters, you can just get information from the weights on CPU, the weights on locking, and that, well, it will probably not work because I didn't configure all the filters properly, all the relations properly. But you could just have a dashboard with specific scenarios to show the whoever is interested in this information, whoever you want to justify any change. And then you have the database run stats. This is a very basic one, but you can create all kind of charts here. So we usually have one that includes the CPU total, the CPU average, comparing the CPU total with the duration total. So you can make any kind of charts here. So the ones we have, I think, as I mentioned, I think we have about 1,000 different dashboards, and some of them have, I think, maybe a dozen or so of different different tabs. So you can get all kind of information there. Different instances, different databases. You can get the information actually any way you want. But I will leave that for whoever is more knowledgeable of Power BI, because I'm just running with the basics here. And just so you can see how these reports are executed. So everything you saw in the Power BI is based on execution, the execution of the store procedures. There are no queries in the execution plan. So there are no queries in Power BI. Everything is based on the store procedure. So it's much easier to modify. So we have the dimensions here. Yeah, I hope you can see. I changed my font, but I think it should be readable. So we have just the basics. So you can see that everything is using a store procedure, and you can modify everything. You can adapt that. The time interval, that is also a metric used for the dashboard to decide what kind of information to store, sorry, to load. So let's say I only want the last dates. There is some extra double zero here because I was planning on maybe adding support for hourly aggregations here, but yeah, the numbers are there, so I could definitely do that eventually. But right now it was way easier to do that on the day level. Also, since all the previous versions we had locally to run this were on the day level, I didn't want to spend too much time on the hour level. If you don't need details at the hour level, you can just go into each server and use this other tool, QDS toolbox, and get some other reports. And information you can get. So if you want to extract data here, or you want to give someone else access to extract data here, you can just run commands. I'm not going to open the plans because, yeah, I don't know what kind of code I might be finding here. But as you can see, so let's say you have a plan on one of your servers. You have the plan hash, but you want to find out what's the plan W key, so you can filter that later on the Power BI dashboard. So you can use the hash, or if you have the plan W key and in the dashboard, and you want to find out what's the actual plan, you can get this information here. So this is not just for the Power BI, it's also so you can just do some reporting here, so you can extract information from here. Yeah, this is not for myself and for my boss, so he will approve the code. So here are some reports on the query text, which is compressed. So this is doing all the decompression. So here you can see all the details. So this particular query text is associated to this query W key with this plan, query hash, unique query hash, and the object had the handle, the query text. Here, this is one example. This query hash unique W key. The query hash is pretty much the same for SQL Server, but there are tiny differences. So yeah, I should have removed that there. So as you can see, all these queries look pretty much the same, but the hash in terms for SQL Server is just the same because it's doing pretty much the same. Also, if you have the query text handle, you can get information from the query text. You can search for a specific code in your query text, and it will get you the list of all the queries and the information. Let's see. I think all this, and this is for a particular object. You can get all its code, not only the code that you're running now, because this is all the query that was captured. So even if you change the code, you can see previous versions of the code. You cannot tell what's the order of the code, but you can see what was the previous version. So when you go into the dashboard, if the code has changed, so let's say you change the code so much that is no longer the same query because you change too much. You make a refactoring of the code. So it's not just like I change the variable name. You change the whole way of processing that. So you can compare different query hash W keys, and then you can go into the dashboard and decide, okay, I want to compare this query hash with this other query hash, these two sub queries of the same object, and I want that on the same dashboard. So I will see that this day, this query has stopped being executed. This new one started being executed, and I can see that this one is performing better or worse. Because we've seen some in our production environment, we see that some changes improve things. Some others were expected to improve things because on the lower environments they were improving things, but then when we hit production because of the amount of data, they were actually performing worse. So that's something that we want to be able to compare. And then some information about the queries. Yeah, just IDs. So you see, okay, this object, what are the queries that it's been using? Just filtering the internal queries. And then we have here information on all the queries. As you can see, it's return all this data in only 1 second. List of objects. Yeah, the first one is just the system object. So if you just have this default dashboard with just the IDs, you can map this object W key with whatever it is on the server level. Sorry, on the database set level. And here, these are the reports that you can run on Power BI. So the Power BI dashboard is based on this. I added some values here, so I just want to get information from the last 5 days. I want to exclude internal queries, ad hoc queries, aborted, exceptions. I want to aggregate all the outcomes. A minimum duration of, I think it's 10,000 seconds, if I remember correctly, what was the metric here. And I don't really care the minimum CPU. I just want to get the queries that are taking longer than that time. So let's say you want to generate a dashboard with just that information. Yeah, it's 7,000 rows, and the more filters you add, you can filter the report. So you can just have Power BI dashboard that are specific for specific issues or specific databases, or you can just run this and get some information here. And some examples here. Okay. This will get you the details at the plan level. You can see here FC run stats by plan daily. There are by plan, by query host, by object. And this is going to be for one specific object. Yeah, as you can see, this is just for the object 83. So let's say you want to show a dashboard for the developers that created that particular object, so they can see what's the impact, and they, for whatever reason, they don't have full access to the server. You don't want them to have full access to the server or to access Query Store. You can extract that information for them. Same. Yeah, I'm gonna skip that. It will be the same at the query level, at the hash level, results of the query execution. Yes, how many were aborted, how many exceptions there were, wait for a given query. Also, these are, yeah, the wording here is a bit weird because wait stats are stored in a different way, in a very weird way in Query Store. So you have total wait time, average, minimum, maximum, and this is the filter. So I want to get information from wait stats from a query whose maximum wait time was at least a particular value. Yeah, it's very weird how they configure that, but yeah, since they already have it, I decided to just store that information like that and let you decide what information you want. Same at the object level, and these are some of the reports that you can generate by T-SQL, and these are the reports that the Power BI dashboard relies on. So in Power BI, I think I can show that. If I remember, they changed this. I no longer remember what it was. But in the variables for the Power BI dashboard, all these parameters I'm showing here, all of them are included as parameters. So you can just change those variables, and it will change how the report is results. But It's been a while since I modified this, and I no longer remember what it was. Was it transform? Let me see. Yeah, manage parameters. So all these parameters you can see here are the same ones that are in T-SQL, since this relies on T-SQL. And that's how you can just generate reports from the SQL on the server, or you can just use that to generate dashboard for whoever might be interested. And since I have it open here, why I'm using the query hash? So I'm gonna find the repeating query hashes and the query hash. So here I have this query hash W key based on the query hash that query store generates. And I see that it repeated 346 times. So it's probably the same one as here. 311, 284, 249, 243. And then we have here 214, which there is no 214 here. But here we have a 243. So let's see why they are different. I'm using the query hash unique W key. So this is the query hash UW key. Let's see why it's not the same. Here we can see that the query text here is different. The plan hash is different, there may be some changes here, and the handle is different. So that's why the same query hash is different. But I think I have it in the same. So let's take a quick look at the query text for those two, 423, 4223, and 44282. And I'm just going to expand it a little bit until you see the difference. Here you see that there is just a extra blank space here, and in Query Store this will mess up all your metrics. You wouldn't be able to compare these two queries, but since I'm using this query hash unique W key, which is not the one that the SQL Server assigns to each query, you can now compare those two. Otherwise, you will think that they are different. There will be no way for you to check that unless you go check the query store, check the query text, remove all the blank space. You do also parsing to get rid of all these kind of duplicates, all the differences. So this is something that we use for the mostly entity framework and dynamic SQL, that we want to get rid of all these duplicates and be able to compare across different databases, servers, and even in the same database, sometimes with this tiny difference that otherwise it will have different hashes. Let me see what else I have here. Oh, something about the configuration I mentioned. So some ways you can configure this to perform the load. So some examples I have here. Let's say you have an environment. Yeah, those are just dummy tests. So database is ending with 0, 1, or 2, or the environment could be just how they are ending. Just sorry. No. Let me let me explain that. So this will be just the description of the database environment. These are the filters. So you can decide that one particular database environment can be the fourth character, maybe a P for production, D for development, or maybe that the last character is because you have different naming conventions. You can apply different scopes here. And then there is a whole set of stored procedures and processes that, based on this, it will generate queues. I try to do a lot of different filters on that, but it reached a point, I think it was like 36 different unions, and the SQL Server couldn't just, it just gave up. I think about when I reached 25 or so, it just decided that there was not enough memory to generate the plans, and this was I think was a 128 gigabytes, and I wasn't even half done with the query. So I decided to just do this information, store some information here and some other generated into different tables. And then the configuration on the database files and file groups. So I have here, there is only one example here, but you could have, let's say, one type of database. You can create them in one file group. In this example, this file group is going to be called file group 01. This is going to be the folder where all the files for this file group will be created. The format for the files, how many files you want to create, the initial size, growth, and maximum size. You can create any number of them here. And when you create a database, it will look into this configuration. If these files do not exist, it will create the files. It will deploy the objects into this file group, and will create everything inside the location you want. When you start dropping databases, if there are no more databases, it will also do the cleanup and remove the files, remove the file group. So it will auto create, auto clean up pretty much all the things. I think can't remember right now if the database, sorry, the folder is being deleted right now because it's been months since I last tried that. But pretty much everything else is done. Then the settings, there is only one example here. The batch size on which the data has been deleted. How much data, how many days of excess tasks you want to retain after the aggregation at the database level, on the hash level, all the batches there. Those are some parameters here, and database aggregation. So you can decide if you want to aggregate that at the query level. It will always aggregate at the plan level because that's the default, but you can decide to aggregate at the query level, the query hash, or the query object, so just disable some of them. Let me see if I have this configured. Yeah. So this is one of the queues I have. I'm just using one queue for these demos. So when I decide to execute one load, which I have here, an example, it will just get whatever is in the demo queue and whatever is the demonstration set, and it will first reset the queue, flag all the databases to be reloaded again, load all the information, and then since the demo queue and the demonstration set are the same set of databases, once I'm done with the database queue, I will just aggregate all the data. And these are the metrics that I was testing this week. It's 20 databases. It's taking about 11 minutes on a daily load, which includes all the extra steps, including maintenance and all that. And intraday, I just run it once that it wouldn't do the daily interval. So the daily aggregation, it just save a few seconds. So this particular example didn't save too much time. And something else about the configuration. I have already masked data here. So this is the database I have configured with obviously fake names and all that. And this is just some example of the configuration. You can do any kind of configuration. As I mentioned, you can create a queue that will only load information from one specific number of databases, or anything on one particular instance, or on one instance but a particular database. So I try to accommodate all kind of different scenarios. So I don't know if you have any more questions. Oh yeah, I forgot about the plan miner. The plan miner is what will get information from the execution plans, and I got some examples here. Queries using a cursor with a name containing PID, and this is scanning thousands of plans. I don't know how many of them right now, but it's extracting data from a lot of them. All this extract is performed as part of the daily load, So once you have the information, once the data gathering and processing is done, you have all this information available. As I mentioned, let's say you want to find any plans that include a KeyLookup because you want to get rid of those. Yeah. There are no details on what's the actual operation, but then with this table, which is a table variable, so you can join this with, let's say, the dimension containing the objects, and you can get the object names in addition to these values. Another example, let's say you want to find any query that is complaining about missing indexes. And in this case, because I wanted to avoid any uh, uh, proprietary scheme, I just decided to go with DBO. So these are the queries based on the execution plans. These are the queries that are complaining about missing indexes. Plans that access this particular column is just in case you want to make a change of the particular column or the particular table. This one takes a bit more time because it scans. It allows you to just, instead of using the values here to add the special characters, it's going to be running like comparisons here. And it's still running. And here I have some other examples, like anything that's performing read and write operations, or you want only to find things that are performing read-only operations. And this can be used, as I mentioned, if you want to grant access to read-only objects. So this will filter this object for you. Or if you want to see if it will be worth it to configure the secondary AG for read-only connections, you can use this to get that kind of information, or just to get a head start, just a filter of the objects that might be appropriate for that, and then you can just go and double check that. I forgot to write down how long this will take. Should have. Okay, 1 minute. So all these subjects, all these queries, all these plans are accessing the ID column in particular. So that's it. If this were a real column, you could just identify which one you want to find out. If you're just interested in a particular table, you can just leave this. I can't remember right now if I made it so it will consider null values or just percentage. I can't remember right now because it's been a while since I had to review the code. But you can make any kind of filter to identify what will be the impact. You can add any number of columns here or any number of objects here. So there is, I try to make this as parameterizable as possible, so it could be adapted to any use you may have. And I think these were the demos I had. Yeah, these were the demos I had prepared. So if you have any questions, I can show you the code or explain in more detail. So how it's aggregating data or how it's performing this semi-parallel load. Any questions you have?
All right, chat, this is your opportunity. If you have questions, get them in here and I'll ask away. In the meantime, Andrew says, I feel touched looking for cursor usage. So I'm sure that was done in his honor.
Yeah. Yeah. Also, speaking of Anders, if any one of you has heard about his urban legend about a table with 100 indexes, that was a nightmare. They were actually 848, and it was running perfectly fine. And that was the first version of this CentralQDS. It was running so fast that it was running faster than the actual query store from Microsoft. But yeah, there were too many indexes there. I decided to move on, and I think this is the third or fourth iteration of this tool.
Well,
And those were filter indexes. They were not overlapping. They were filter index. Yeah, it wasn't that bad.
I will also concur with Anders here. Great presentation, definitely usable. And I think now's a good opportunity. So I have the GitHub repo for QDS Toolbox, which is publicly available. I'm going to drop that link in chat. Are there any other repositories or places where we should be looking?
Well, you can check the SQL Top from Mark Wilson, who is my manager also. It's like some like the top tool for Linux for whoever uses that OS, but for SQL Server. And the repo for CentralQDS, I still have to clean that up because I have the internal repo and it has a lot of reference to our code, or passwords and everything in there. I have scripts to uh, drop and recreate the whole thing for a particular environment, but I have to clean that up. And I wanted to see what people think about this, what scenarios or what functions they think that could be useful here, so I can think about adding them before I I release that in GitHub.
Okay, fair enough. And in the meantime, the QDS Toolbox is publicly available, so you can check that out. And once this becomes available, uh, we'll find a way to get that info out there. Andrew says this would be very usable in a load test environment where query store is not persisted. Yeah.
Yeah.
Uh,
Uh,
as
i-
well as
if
the example
if
here,
you
a
wanna
very disparate environment.
yeah, if you want to try the QDS toolbox, I have some post in my blog, which I think it's been a year since I posted anything. But well, is it sqljare.com? Hmm? Jared Poach. Kevin, do you know the his blog?
Oh,
I think
yeah,
it's
yeah. SQL Jared, yeah.
yeah. So he usually when I make any change, he usually tests that out and usually posts about the new feature or the change that I've made. So he writes when I do some posts, he usually goes and see what I've done and post about some other feature of the tool. Yes, he also adds some examples and some analysis on that.
Yeah, I'll drop a link to an example that looks like last time he talked about QDS Toolbox was roughly a year ago, but there's some posts in there to check out.
Mm.
So
Yeah, and I
very
think Malab may have this in Bombard, but Grant Finley mentioned us in what was it, SQL Pass, and in his blog because I think it was 3 years ago he saw the first version and he liked what we were doing here with Query Store.
yeah. All right, looks like no other questions. So I don't know if you have a wrap up slide or a place where people can contact you. Easy way to get in touch.
Well, I can go back to this. Yeah, so that's my Twitter handle, my website, my LinkedIn, and on SQL Slack. I'm thinking that maybe when I finally release CentralQDS, I see that some people has released mm, some other open source tools, and they have some channels on the SQL community. So I may do that. So if anyone has any questions or any problem with that, they can complain about that. There on the GitHub, I had some bugs on some changes on QDS toolbox that I already addressed. So yeah, you can reach me because when I'm bored, I usually try to do anything but checking backups and all that. So I always have a bunch of things I want to modify here, and sometimes I test that for a long time on our production environment, which is something I shouldn't be doing. But yeah, I test that on production because that's where we have uh, the most database and the most activity. And when I see that it's ready, I release that to GitHub. So pretty much whatever you can see on GitHub is something that we have thoroughly tested in production.
Very good. Looks like no questions. So I'm gonna say, following on what Mark mentioned here, thank you, Pablo. Definitely appreciate you staying up late, and let's wrap things up so you can get to sleep at a less reasonable but not entirely unreasonable hour. So again, we certainly appreciate you taking the time this evening to talk to us about CentralQDS. Looking forward to public release of it. And in the meantime, everybody, remember that our main meeting will be next week. Our BI and data science meeting will be 2 weeks from today. Until we see each other again, everyone, take care.